This is the overview of our dynamic network analysis and visualization tool. In our tool, we have a node selection pool, a node and the connectivity amount text area, a dynamic graph, and a time bar. Users can choose whichever interesting time period to analyze by moving the time bar. The node and connectivity amount in this selected time period will be shown in the text area. Nodes in the selected time period can be sorted according to their weighted degree or unweighted degree in the node list. Users can choose whichever interesting nodes to analyze by selecting them in the list. Selected nodes along with their connectivity will be shown in the dynamic graph. Our graph supports some basic graph interactions such as zoom in, zoom out, drag, and pan. To improve our graph's scalability, we have also added the edge weight filtering and maximal hop selection functionality into our tool. Nodes in our graph refer to entities in dynamic network. Links are used to represent connectivity among entities. Links in our graph are divided into multiple segments by their temporal dimension, and we use different colors to show network's dynamic topology and properties. As we can see that we use black color to denote the start time. Light green colors indicate that two entities are not connected during certain time period. Other colors are used to show connectivity's dynamic property values. By using its temporal dimension, we achieve the goal of showing big networks dynamics over time in one single and static view. To find out the Wendelism discovery time in West Challenge 2015, we first move our time bar to choose the whole time period. We then choose to show all nodes in the network by weighted degree. As we can see from the node list that there are three IDs which stand out for their weighted degrees. We first set our minimal connection amount value to 340 and select the ID which has largest degree value. As we can see from dynamic graph that this ID's connectivity with other entities always start at entry corridor and show a back and forward trend. We hence assume that this ID maybe is one kind of park service which located at entry corridor and is trying to check other entities' park app status. After knowing the pattern of the first ID, we then go to the second ID. As we can see from the dynamic graph that the second ID's connectivity with other IDs tend to start at different locations but always end at entry corridor, and they also show a back and forward trend. Based on these patterns, we assume that the second ID maybe is also one kind of park service, such as information desk, which is located at entry corridor. Thus people will contact for questions. When analyzing the second ID, we also find one pretty interesting pattern. On Sunday, around 11 a.m. to 5 p.m., the second ID has much more frequent connectivity with other entities. To further find out the details of this pattern, we dig down into the suspicious time period on Sunday. When we move our time bar to explore the dynamic graphs on Sunday, we find one really interesting time period. As we can see from the dynamic graph that since 11:52 a.m. on Sunday, other IDs started to frequently contact with the ID that we assumed to be the information desk and the external at wetland, where the vandalism was happened. Based on this pattern, along with the previous patterns, we know that the vandalism was maybe discovered at 11:52 a.m. on Sunday. Since that time, visitors started to frequently contact with the information desk and the external to know the details of vandalism. That's all. Thank you.